Hello students, and welcome to our lesson on compound interest. This is the follow-up to our lesson on simple interest, so if you have not watched that one yet, make sure you go back and do so. What compound interest is going to do is take simple interest and have it happen over and over and over again, so that way it builds on itself. So let's get right into it. Compound interest is another way to charge interest on a loan or earn interest on an investment. So it can either be you paying money or you making money. Can go both ways depending on which side of it you're on. With compound interest, the interest is calculated several times over the course of a loan or investment. This is the opposite of simple interest because simple interest, we just have it happen once over the course of the loan, but compound interest, it'll happen more than once, so several times. The interest accrued is added to the principal before the interest is calculated again. The result is interest being accrued on interest. So the result is interest being accrued or earned on interest that was already accrued or earned. So the idea of it compounding is that not only is the principal, so the original amount borrowed, earning interest, but also the new interest is earning interest on top of itself. So let's go ahead and see an example of how it works. On the left, we're going to talk about simple interest, which is what we did last topic. If you invest $1,000 at 2% for 1 year, we can go ahead and use our formula for simple interest, I equals PRT. If we plug in our values, we're going to have that interest here is equal to $1,000 that we invest multiplied by our interest rate turned into a decimal. So 2% is 0.02. And then 1 year, so we'll multiply by 1. When we calculate that, nice easy math here because we're multiplying by 1,000. 1,000 times 0.02 times 1 gives us a total interest value of $20. Okay, so over that 1 year, we have earned $20. And so we can then say that the total amount of money we have is equal to the $1,000 we started with plus the $20 that we just earned. So we have in total $1,020 at the end of this. So simple interest is called simple because not too much happens. We earn 2% interest one time over that year, and then we add it to the amount we invested. So we earn $20 and we end up with $1,020 at the end. Compound interest is going to have this happen more than once. So for compound interest now, it says $1,000 invested at 2% compounded twice for a year. So compounded twice means we're going to do this 2 times. So twice for a year means once every 6 months. Okay, so we're going to have 2 different simple interest periods. We're going to do it twice in a year, but that means we're going to earn simple interest in the first 6 months and then again in the second 6 months. So we can use the simple interest formula still, where in this case, I is going to be equal to 1,000 multiplied by the 0.02. But this time, the number of months that we're doing is only 6. So in a year, we compound, or sorry, the time we have here is 6 out of 12 months. Because our interest rate is per year and we're doing it for 6 months, we convert 6 months to 1 year by doing 6 over 12. Okay, so 6 over 12 right here, we can also say that that's 1/2 years. Okay, so that 6 over 12 is the same as 1/2, half a year. The interest we earn here, if we multiply this out, 1,000 times 0.02 times 6 over 12 is going to give us $10 in interest. Okay, so now we're going to do it again. All right, we now have $1,010 and we're going to run the same process. So now for the second 6 months, we're going to calculate interest where this time we have $1,010. Notice 1,010, I added the original 1,000 with the 10 that we just earned. So our new principal is 1,010. We're going to multiply this by 0.02 and 6 over 12 again. So another 6-month period. When we multiply that all out, This time the math is a little more complicated. So we're going to get interest equals 2, and this time a little less obvious what we're going to get, so I'll show you on the calculator. 1010 multiplied by 0.02 multiplied by 6 over 12 gives us 10.1. So this time we earned $10.10. Okay, so the interest is 10.10 or $10.10. So our new total is we started with our original $1,000, then we added $10 in interest, and then at the end we added another $10.10 in interest. So when we add that all up, we have $1,020.10. Notice that that's not the same number, okay? We invested for the same amount of time. It was a 1-year period. The only difference, we had the same interest rate and the same principal. The only difference is the fact that we compounded twice. So the exact same money invested with the exact same interest rate for the exact same amount of time, but we compounded it twice. So at first we earned $10 in interest, and then that $10 right here, this $10 earns an additional 10 cents in interest. So we go from having $1,020 at the end to $1,020.10 because this initial $10 we earned its own interest. That extra 10 cents is from the original interest from the first part. So the takeaway here is that when we do compound interest, it allows the money to grow faster because the interest is growing its own interest. So it's compounding, it's building on itself. All right, so now we have a formula that instead of calculating this one step at a time, we can calculate it all at once. So instead of doing one simple interest and then another simple interest, we can go ahead and just do one formula that'll calculate everything. So the compound interest formula right here is A equals P times 1 plus R over N to the power NT. We're noticing that exponent NT, that is N multiplied by T. All right, so we have a few pieces to this. Some of them are going to feel very familiar. A is the total amount you have, or the final amount. Okay, so A is the total amount you have, or the final amount at the end of the investment. So at the end of our investment, we end up with A. P is the principal, just like it was before. That's the amount you're investing. R is the interest rate, which is given as a percent, but we always turn into a decimal. T is the time, which must be in years. Okay, notice this time it must be in years. And then N is the number of times that our investment or our interest is compounded per year. Okay, so we have two new variables here. We have A and we have N are new. We're going to talk a little bit more about N in a second, but first let's talk about A, because this is a little different than the simple interest formula. When we use the compound interest formula, the amount we get for A is not the interest that we earned. Okay, A is the total amount you have, or the final amount at the end of the investment. It is not the interest. So right here, we're going to actually make a little change. You can write this on the side, or you can erase and put it in the same spot. Where we say final amount, what I want to make clear, A is the total amount you have, interest plus principal. So instead of simple interest, where we just solve for I, so notice above, when we did simple interest, we just solved for interest using this formula. Here, A is not the interest. A is the interest plus the principal. So it's both pieces together. This is very important to realize because in some questions, we might want to know just what is the interest earned. And then we'll have to do an extra step where we subtract the principal from the interest, or sorry, from the total amount to find the interest. So A here is not just interest, it's interest plus principal. All right, so now let's talk about n. N is the number of times we compound in a year. Usually we don't just say how many times it compounds though. Usually we describe it. So we have a few different things that we use pretty often. If we say annually, that means n is going to be equal to 1 because annually would mean it happens once per year. Semi-annually would mean n equals 2 because that means it happens twice per year. That's the one students forget the most, by the way, so pay extra attention. Semi-annually, twice per year. Quarterly, that one's a little more obvious. That happens 4 times per year. Monthly, we have 12 months in a year, so it happens 12 times. Weekly, you might not know that there's not exactly 52 weeks in a year, but when we say weekly, we use the number 52 because quite honestly, it's close enough for our purposes. So weekly is 52 times a year, and similarly, daily, we use 365 times per year. Even though if there's a leap year, it would be 366, we just assume 365. So now let's go ahead and compare these two formulas. Simple interest on the left side has this formula, I equals PRT. This formula calculates the interest amount only. Okay, so this is the major difference, is this only calculates the interest. It's calculated once over a period, and interest is accrued on the principal only. So in simple interest, it only happens once, it's only accrued on the principal, and the amount we solve for, this I variable, only represents the interest. On the other hand, we have compound interest, where this formula calculates the total or the final amount. This is calculated n times over a period. So not just once, but n times, however many n is. And interest is accrued on the principal and the interest. So the main important things here are the fact that interest earns its own interest when you're using the compound interest formula. We're going to calculate n times, so we're going to do the simple interest over and over again, but this formula does it all at one time for us. And the most important takeaway is that this gives us the total amount, okay? Not just the interest, it gives us the total amount at the end of the period, principal plus interest. All right, so now let's do a couple examples. So number one, a rural clinic invests $4,000 into a fund to purchase updated imaging equipment. The account earns 8.25% interest compounded semi-annually. How much money will the clinic have after 5 years? When you read this problem, the first thing you should do, quite honestly, is just jot down the formula. So we're trying to plug into A equals P times 1 plus r over n to the power nt. Okay, once you have your formula, then you're looking for each of the variables that's given in the formula. So we're going to reread the problem and we're going to make a note of which variable each thing represents. So it says a rural clinic invests $4,000. If they invest 4,000, that is our p-value. All right. They are purchasing imaging equipment, which although that's nice for context, it doesn't actually affect how we're going to solve. The account earns 8.25% interest, so that is going to be our R value. The interest is compounded semi-annually, so semi-annually tells us that n is equal to 2. And then it says, how much money will the clinic have after 5 years? So 5 years right here, that's going to be our t value. And when it says how much money will the clinic have, that is our a value. So the only thing we don't have is a, which means all we have to do is take our other values, plug them into the formula, and then type it into a calculator. When you're solving for something other than a, then it's a little bit more work, right? Then we have to isolate a variable by solving the equation for that variable. But in this case, a is already isolated. So this formula is solved for a, and it's written in terms of p, r, n, and t. So if we have p, r, n, and t, all we have to do is plug them into the formula. So all we're going to do is plug in our values. We're going to say that a, well, let me put that in red because that's the thing we're solving for. A is going to be equal to our principal, which is 4,000, multiplied by 1 plus, we're going to do r over n here, where we have to turn r into a decimal. So we're going to put 0.0825 on the top of our fraction, and we're going to put n equals 2 on the bottom of our fraction. And our exponent is n times t. So 2 multiplied by 5 for that exponent. Notice that 2 shows up twice in this formula because the n shows up twice. That might feel a little bit weird that we have the same variable twice. There is a very good reason for you, though. If you are at all interested, we can always work through where this formula comes from, but there won't be an explicit proof given in these notes. But okay, so we have everything plugged in. Now we can just go ahead and type it into a calculator. So we're going to pull out our calculator. We're going to type 4,000 multiplied by, so I'm going to use parentheses, 1 plus, I'll create a fraction, 0.0825 divided by 2, close my parentheses and make an exponent, 2 times 5. And if you saw what happened there, it put my times 5 on the side. So just make sure you're always being careful with your calculator. When I type that 2, if I put parentheses, it'll allow me to type 2 multiplied by 5 up there. If you don't put parentheses, then it's going to make you just write the number 10 instead. So just be careful when you're typing, because a lot of students do tend to have trouble when they're putting complicated things in the exponent. So use parentheses wherever you do that. All right, we get our answer over there. At the bottom, it says 5,992.5, and we'll round that to be 5.3. So we're going to go ahead and come down here and say that our A value is approximately 5,992.53. And this is measured in dollars. And this represents the amount of interest we've earned plus our original principal. So what this means is that the clinic will have $5,992.53 after investing $4,000 for 5 years. So then if we wanted to say what the actual interest is, so a little bonus here, okay, we could say that interest is 5,992.53 minus the original investment, which is equal to 1,992.53. So we have about $2,000 in interest earned on this $4,000 investment. So it's important to realize that the formula we just used solves for the total amount. So if we want the interest, we have to subtract the principal from that. All right, number 2, a healthcare nonprofit invests $5,600 to a fund or to fund a future laboratory renovation. The account earns 7.5% interest compounded daily. How much interest will be earned after 3 years? So this one is specifically asking us how much interest will be earned. So we're actually solving for I, which is none of the variables in our formula. So in order to get that answer, that part I did in pink just a second ago, we're going to have to do that step at the end after solving for A. But first, what we're going to do is just copy it on our formula. A equals P times 1 plus R over N to the power NT. And then we're going to find all our values that we need. So we can see that 5,600 is the amount invested. So that's the principal. It's 7.5% interest. So that's our R value. Compounded daily. Remember, daily means N equals 365. And it's for 3 years. So that's our T. So we can go ahead and solve here. We're going to say that A is equal to our principal, which was 5,600, multiplied by 1 plus, we have to turn our interest rate into a decimal, 0.075 over 365, which is our number of compounding periods. We're going to raise this to the power NT, which is 365 multiplied by 3. All right, we can go ahead and type this all into a calculator to see what we get for A, and then we'll have one step afterward to get the interest. So 5,600 multiplied by 1 plus, make a fraction, 0.075 divided by 365, and raised to the power, where because I'm multiplying up there, I need to use parentheses for my exponent, 365 times 3. That gives me $7,012, and I'll round that to be 85 cents. So 7,012.85. So we're going to go ahead and say here that A is approximately $7,012.85. So the investment is worth a little over $7,000 at the end of this 3-year period, but we don't want to know what it's worth. We want to know how much interest was earned. So to solve for that interest, what I'm going to do is subtract the original $5,600 that we had before. And this is going to tell me that interest is equal to, when I do the subtraction, I can just take my calculator back out. I already have the original number there. So if I just push answer and then subtract 5,600, it gives me 1,412. And again, we'll round that to be 0.85. So 1,412.85. So this account earned $1,412.85 in interest. And in this case, that would be our final answer. I just want to clarify that on the previous question, our final answer was not the interest. The final answer was the amount of money earned at the end, because it was asking us how much money will the clinic have. So it's the total amount at the end. Whereas here, our answer is the amount of interest. And so I'm going to go ahead and put into a box this 1,412 number, because the question was specifically asking us how much interest was earned. And then I'm going to go ahead and change this red eye up here to a pink eye, just to make sure our colors are nice and clear. All right, so now we're going to go the other direction. Okay, we have now a present value formula where it says P equals A divided by 1 plus R over N to the power NT. Hopefully that formula looks very familiar, because it's the exact same thing as the compound interest formula, just solved for P. So if I take the original formula, okay, if I take A equals P times 1 plus R over N to the power NT, and I divide both sides by 1 plus R over N to the power NT, if I divide both sides by that, I'm going to get P by itself, and I'm going to get A divided by 1 plus R over N to the power NT. So all that's happening is we're dividing by all of this on both sides. That makes P isolated, and it leaves A divided by this whole thing here. So all we're doing is taking the compound interest formula and solving it for P. All right, so now what this is going to do for us is tell us how much money you need to invest in order to reach a certain account value at the end. So it's telling us what the principal needs to be in order to reach our goal. So number 3 says, a public health agency wants to have $250,000 in 20 years to purchase a mobile clinic. And they invest now at 12% interest, compounded quarterly. How much should they invest today? So we have the formula right above there. P equals A over 1 plus R over N to the power NT. And what we're going to do is plug in each of the components we have. We want to have 250,000, so that's going to be our P, in 20 years, so that's going to be our T. So if they're investing at 12%, which is our R compounded quarterly, then we have our components. We have, oh, sorry, my mistake. I wrote P up there for 250,000. That is the A value that we're trying to solve for, or that we're plugging in. So we want to have 250,000. So that is the end account value. That is the A here. That is arguably the most important part of this problem, by the way, is that we recognize that the 250,000 is the thing we want to end with. So it's what we want to have, not the amount we're investing. Okay, what we're solving for here is the amount we're investing. So we're solving for principal. My apologies there. So now that we have our variables though, we can go ahead and just plug into the formula. We can say that P is equal to the end amount we want in the account, the $250,000 number, divided by 1 plus R over N to the power NT. So 1 plus R over N, our R is 12%, so I'm going to write 0.12 divided by our N is 4. So 0.12 over 4 to the power 4 multiplied by 20 because our number of years is 20. Now again, we're just going to whip out a calculator and go ahead and type this all in. So I'll start by making a fraction by hitting the divide button. I'll put 250,000 on top. And I'll go to the bottom. I'll put in parentheses 1 plus, and then a fraction, 0.12 divided by 4. I'm having trouble getting these numbers inputted. Over 4. And raise this to the power, where again I need parentheses for my power, 4 times 20. So you can see it gives me a calculation over there on the side. It tells me that the p-value I need is equal to $23,494.27. Now, that might be a little bit surprising to you. Okay, so let's take a look. We only need to invest $23,000 in order to have $250,000 in 20 years. I know $23,000 is not a small amount of money, but just think about the fact that this is not even a tenth of 250,000. So that means over this 20-year period, we are getting a lot of interest on this. And there's two main contributors for that. One is the fact that 20 years is a pretty long time to be investing, but also 12% is a very high interest rate. All right, if you can get 12% on an investment, that is a very good rate of return. And so that's why we're able to invest such a small amount to end up with such a large amount. All right, we have one more. Number 4 says a high school student plans to attend nursing school in 5 years and wants $12,000 saved up by that time. If they invest 7% interest, or if they invest at 7% interest compounded monthly, how much should they invest today to meet their goal? So taking our formula of P equals A divided by 1 plus R over N to the power NT, we're going to go ahead and plug in each of our pieces. Where it's 5 years away, so T is 5. They want to have 12,000, so our A value is 12,000. 7% interest gives us our R, and compounded monthly tells us that N is equal to 12. Where the thing we're solving for is how much should they invest today, which is our P. So the fact that we're solving for how much we should invest today is the key that we should use this formula, not the compound interest formula from before. But remember that they're really the same formula, just solved for a different variable. So even if you use the wrong one, you can always solve for P at the end just by solving that equation. So as long as you label the variables correctly, it doesn't actually matter which formula you use. It'll just be an extra step if you use the wrong one. All right, we can go ahead and plug in our values. We're going to put our A value of 12,000 on top, divided by 1 plus, we have an R value of 7%, so that's 0.07, divided by 12, which is our N value. And then we'll raise this to the power 12 multiplied by 5 because we have a 5-year period here. So pulling out our calculator now, we can go ahead and say 12,000 divided by 1 plus 0.07 divided by 12, close my parentheses and raise it to the power 12 times 5. This tells me that that student needs to invest $8,464.86. So this gives us a p-value of $8,464.86, which notice this is not very far off from the amount they want to have. At the end of this period, they want to have $12,000, and we're saying they need to invest $8,000. Well, those numbers are not that different from each other. In the previous problem, we wanted 250,000 and we only invested 23,000. So it should feel very different, those amounts of investments. But notice two key details. The time is far shorter, so the investment does not have nearly as long to mature or gain interest. 5 years versus 20 years in the previous problem. And the other thing, which is also very, very important, is the interest rates are drastically different. 12% is far higher than 7%. Okay, it's nearly twice as much. And so a combination of having a very small interest rate and a very short time period causes this to go way awry. All right, so now we're done with the notes, but I do want to show you a little bit more about compound interest before we move on. So I'm going to pull out Desmos. I'm not going to use the scientific one though we've been using. I'm going to flip over to the graphing version of Desmos. And what I'm going to show you is that you can actually kind of play around with these formulas to see what you need. So I'm going to use the present value formula just for sake of fun. So what I'm going to do is I'm going to type in the formula the way we see it. I'm going to put P equals, and then I'm going to put in my fraction, A divided by parentheses 1 plus, and then we have R over N. So R divided by N, and we're going to raise it to the power NT. So N times T in this exponent here. So now notice what Desmos does. It allows me to add sliders for A, R, N, and T. I'm going to go ahead and click the All button and see how it puts down below all these different values. So now we can just play around with these. I can literally slide them all around, and notice in the top right, it shows me, in this case it says 1.2, it shows me what I would need to invest today. It solves for P based on the values I have down below. So let's say that we want to talk about retirement. Okay, so now this is not the only way to look at retirement. This is only the compound interest formula. But what you'll learn later on, if you take a financial algebra class, is something about annuities and sinking funds and other investment related things. So this is just a brief introduction. Let's say when you retire, you want to have $1 million. Okay, so 1 million. How many zeros do I need there? That's 100,000. There we go, 1 million. If we don't change anything else about this, okay, in order to have $1 million, we would need to invest 500,000, where what happened here is I didn't change the time, number of compounding periods, or the R. And so all it's doing is dividing by 2 in this case. But if we change these R values, let's say that we have 10, or let's even say 9% interest. So 0.09 for R. Let's say it compounds monthly, so 12 times per year. And let's say that we have a long time. Let's say we have 45 years until we retire. Okay, well, we can go ahead, having all that in. We can now look, and it says that we need to invest $17,687 today to have $1 million by the time retirement comes. Well, let's play around with this a little bit more. What if I change some of these values? What if my interest rate is not 0.09? What if it's only 0.08? So I change it to 0.8. It now says that I need to invest $27,000. Whoa, okay, so having a different interest rate makes a big difference. Well, 45 years is a long time. What if I only have 40 years? If I want to have $1 million in 40 years at 8% interest, whoa, look at how much bigger that number is now. $41,000 is what I need to invest. Okay, well, we want $1 million. I'm not going to change that. But let's say instead of 40 years, let's say we wait. So if you are currently 20 years old, 40 years gets you to 60, which is roughly the retirement age. Let's say you wait 10 years. All right, you still want to have $1 million when you retire, but you wait. And so now you're 30 and you only have 30 more years. Well, take a guess at what you think the amount you need to invest in 10 years will be in order to have that million when you retire. It's now $91,000. So notice by waiting, it went way up. We're investing, or we're trying to get to the same goal at the end. But in order to get to that goal, the longer we wait, the bigger that investment needs to be. If we wait even longer, let's say we only have 25 years, well, now I need to invest 136,000. Let's say I only have 20 years. Now I need to invest 202,000. But let's go the opposite. What if I have 60 years? Okay, not very many of us hopefully have 60 years to retirement, but if you did, wow, then you only need to invest $8,000. All right, so you can play around with this. And again, in a financial algebra class, you'll learn more formulas and more ways to look at interest. But compound interest is your first introduction to how investments mature over time. And what I want to get across to you is there are two things that are very important: the amount of time, so the t value, and then the interest rate, which is the r value. So if I leave these two things the same, t is 45, r is 0.1, notice I need 11,318. Okay, so remember 11,318. If I change the n value, instead of being 12, let's just say I make it 1. Well, now I need 13,000. 13,000 and 11,000 are not that different. If I make n 100, now I need 11,100. So 11,000 and the original 11,300, still not that different. So notice changing that n value didn't do much. But if I change this r value to, instead of being 10%, which is what 0.1 represents, let's make it 12%. Notice how much that number changed from 11,000 all the way down to 4,500. Okay? That R value and the T value at the end are the two things that make by far the biggest difference when it comes to investing. So rate of return and time are your two biggest variables that you want to control. All right, that's all the talking that I'm going to do. My goal of this was to convince you to go and put some money into a retirement account today. Do not wait. Go do it today. And that is always the right answer. I am not a financial advisor. I'm a professor of mathematics. But my advice to you, again, not as a financial advisor, is the sooner you can invest, the better, because more time equals more interest earned. All right, that's all I have for you guys. See you next time.